Hi everyone, it's Patrick from 8-Bit Doodads, and today I thought we would do some benchmarking various storage devices for the Apple IIe. In fact, I have a handful of them over here, such as the new Cirtech clone SCSI interface, as well as floppy emus, uh, BootIs, Microdrive Turbos, the CFFA. So stay tuned so you can see which one is the speed demon.
Say, kids, what time is it?
It's 8-Bit Doodads time!
Okay, first off, I thought I'd start by talking about what I had to do to set up or to do the benchmarking. I used good old Google and found that there were two benchmark utilities written, and I think there's a third one out there I want to find. But one will work on an Apple IIe, and the other one is specific to the Apple II GS. And I actually have another IIe and a GS set up over there that I'll be using for some of the benchmarks. I am going to show you the two different benchmark utilities and run through them, but I'm not going to have video every single machine doing every single storage option running the test. I think what I would do is just show them to you and show you what the results are. And then at the end, we can put up a chart comparing the different systems. To get started, one of the benchmarks that I wanted to do for a long time was how fast is the Corvus OmniNet, because it's a storage device, but it's also like a network attached storage system. And you are limited by the speed of the network, which in the case of Corvus is 1 megabit. As you see, I actually have Corvus loaded up on this machine. There's the transporter card, and the other thing that I have in here is my VGA card, which is how we're capturing the screen. And something I want to point out is right here, you probably can't see it, but that's the standard ROM chip sitting on top of one of the no-slot clocks to keep track of time. The first benchmark software you use requires a time card or timing device built into the machine. I found that out when I tried to run it on another IIe that didn't have one. Luckily, I had a Thunder clock, and if you've seen those, they take two batteries, and I had stored it with the batteries pooled, so it didn't drain the batteries. But when I put it in the machine, it was acting really wonky. And I think I said last video, don't make assumptions as to what you think the problem is. I went and put a voltmeter on the batteries, and they were coming up 152. I thought, that's pretty good. I happen to have a spare set, and I voltage those, and they were 154. So I thought, okay, it's not going to be the voltage. And after trying several different things, yeah, I swapped the batteries. Works fine. So anyways, I'm going to log into the Corvus OmniNet. I happen to have a local or personal account, and you can see it coming up here. Now, I have put some utilities in the utilities folder, and one of them is the disk test. This particular piece of software not only tests drives, but it also, not only can give you a benchmark, but it can also test drives, which are great for if you have SCSI, physical SCSI devices, and you need to check to make sure there aren't bad sectors. It can low-level format drives. It can do a couple other things. So I'm going to go ahead and start this utility. You can see the SPF utility is loaded. Okay, you can see the menu came up, and one of the options is to list the volumes online. And we can see here that there are 4. One of them is the RAM card. Now, one of the interesting things I've noticed about this particular piece of software, and I've run it on a couple machines, is no matter how big a extended 80 column card you have, and in fact, in this one is either a 4 or 8 gig card, it only reports 127 blocks. I think that's fine because the only test it will do on a RAM card, anyways, is how fast it does a block read. And I've seen the same behavior both on here or on a GS. And just to show you that, we'll do a time test and select the RAM drive, and it's going to go out and do a read. And you see it came up with 31 kilobytes a second, which would be equal to 310 kilobits a second, which with our network card, remember I said it was 1 megabit. So in theory, the network should be 3 times faster than that. Now that's actually not going to be true because there should be nothing faster than reading and writing from the RAM drive. But I'll go ahead and do a time test on one of these, and I'm probably going to have to speed this up. If you have a small volume, it basically creates a file and reads and writes from it, and it does several different tests. In fact, go ahead and get this started so you can see. Oh. Okay. That volume is, you're seeing it just finish quickly. The volume must be set for read only. So I need to go back into Corvus and set to read write. In fact, that's something I want to show you. Show you what I'm doing to set up for the GSOS tests or GSOS tests in a few minutes. I know PK Pro is the boot volume, so it's writable. And so when I start the test, it will try to create a 512K file and test the read and write of that. And then it'll try to create a 1 meg file, 2 meg file, 4 meg file, etc. That volume is either only 2 or 4 megs, so it's not going to complete all these tests. And that's why that first volume saw up there, which was the ProDOS test volume I had built, I made it big enough to handle any of these test sizes. It may be that when I created that count, what I didn't do was change. I needed to go into the user side. I made the volume be able to be read-write, but when you add a user and you grant them rights to other volumes, you still can set whether that particular user has read-write access to the thing. And the reason you might do that is, let's say you had a volume called AppleWorks that had ProDOS and AppleWorks on it, and you wanted to be able to, have anyone be able to log in and use AppleWorks. So they would only want read-only access. You don't want them messing with your installation, but you want to give one user, the administrator, write access so that you could load updates onto that, or maybe you'd be putting templates in a folder on there that gets shared. So a volume has what its parameters are. The user also has read and write access. So I'm going to manage access. The PK Pro is not because I'm a professional, it's because it's my account for ProDOS. I think I have a similar PK CPM, and I'm going to have a PK Pascal. All right, so here we got the access list, and as you can see, they're set to read only. You can also tell it what slot and drive you want a particular volume to be in. And you can see this takes a little while because it's actually having to issue a whole bunch of commands back to the OmniDrive. That those first two reserve volumes, that's where all these volume names, usernames, that kind of stuff goes. So, and it has to sit there and update that table. And if that table, if a block in that table is a bunch of, is 8 different volume names, it actually has to read it back, put the update in there, and write the whole block back. The disk server is not intelligent enough um, to, handle that kind of work. Literally, the only thing the disk server can do is read and write a block off the drive. And so you'll see it's doing this again. We'll go back to our utilities. And now it's actually working. You'll see the little spinning thing up in the corner. And because that's a 5 meg volume and the largest file it's going to write is 4 megs, it should do every one of these tests. Assuming it doesn't create each of these files and only delete them all at the end, in which case you would need 7.5 megs of free space. I'm going to go ahead and let this run. If I remember correctly, the first time it was 11 and 10. This was 30, and these were 18. So we'll see what they are at the completion of all 4 rows, and if it picks up any speed or if it just stays flat. I will mention this really is just testing the network and how fast the controller board in the OmniDrive is working. That particular OmniDrive does not have a physical hard drive. It has a hard drive emulator, which basically you don't have any seek issues, seek times and delay in reading and writing. So it's as fast as the wires can be between the devices. Okay, as you can see, it did not run the 4K tests, and I watched the running of this time, and I noticed it's doing all of the write tests first, and then it does the read tests. So clearly, one of the issues is that you need enough space for, as I said, you need almost 8 gigs of space, and I only made a 5 gig volume. I'm not 5 gig, 5 meg. I'm not going to fix that for this and run it again. But what I am going to do is I do want to run this test while it's also running on 2 other machines to see what that does. And what I'm going to do is I'll start the test. I'm going to start the test on the 2 large volumes so that they're running a long time, and then come over here and start the test on this PK Pro volume, and because it'll give us pretty quick results. So let me go ahead and get it queued up and running on the other machines, and then we'll come start it here. Okay, it's running on the GS and the 2E. It'd be interesting to see if the GS is any faster than the 2E is, or either 2E. And of course, what will the overall effect be on this test? Now, I believe it's only going to run the first 2, 512 and 1024, but we'll run the first 3 on the other machines. Well, now that turned out to be very interesting. As you can see, our write and read speed and even our block read dropped down to 1/3. I think they were at 10 and 11, so it's actually slightly less than 1/3. And the file read is at 4. Looking at the other machines, they all dropped as well. And their block reads were even down 18 and 22. And I think the only reason that that is that block read test is the last thing that's done, and this had already finished. So it got some of this. It was cutting the 40 in half, splitting between those 2 machines. But when those machines were doing all their read and write stuff, this really suffered, this machine. So it was an interesting experiment. I don't think I'm going to do anything more on the Corvus side. I'm now going to move to these other machines. Now, one of the things I have to do is I need to put the read test on something, not the read test, the speed test that we've been running. It's a single disk floppy. Something like the CFFA, I can have it loaded as well as a disk image to try the speed tests on. But if I'm testing things like the FujiNet, I guess one of the things I could do is load that FujiNet image up on my server, and I have the FujiNet server, so maybe I really don't need to do anything more. But possibly it would just be easier to put one single 5 1/4 inch floppy drive on here and use that to boot, and we'll run all the tests on here and produce the results. I do, if I have time, I want to run the same tests on the GS, and I want to run some of these tests with and without accelerators. I have both this accelerator and the Fast Chip 2E, which is even faster. So I'm going to run those tests, and I'll come back and summarize them once I have all the results. Okay, we're ready to proceed on our next test. For the first one, I'm going to test the CFFA floppy and hard drive controller. What I've done to make my life a little bit easier is I put a Yellowstone card in here with a floppy emu attached to it, which has a single floppy selected, and up on our screen it's the test disk. So I can use this one bootable disk and keep changing the cards in here. Now for this test, I went ahead and created an 8 meg partition on or volume on both the CF card and the USB stick. I thought it'd be interesting to see if there's any speed difference between those two. So I'll go ahead and run those now. And you can see I've labeled them CFFA USB and CF. Okay, so I've ran the tests on both the USB drive image and the CF card drive image, and they're both very similar to this. I think there's one of these numbers. The 70 was a 73 on the USB stick, and that could just be an anomaly of how the blocks are laid out or what have you. Really no difference at all. This is on a stock 2E. I'm going to now try to put in my fast chip and see if that makes a huge difference. And if it does make a huge difference, I'll probably put in the transwarp as well, because that's only about 3.5 times as fast. And this can go up to 15, 16 times as fast. So I thought that would be interesting. Okay, so this was a little interesting. I've put my fast chip 2E in here running at full speed. I had to make sure the card slot 7 was set at fast, not at slow down to 1.0 speed. And I ran it on both the USB stick and the CF card. And it turns out that the CF card is just a little bit faster writing than the USB stick. Here you see 64, 60, 62, and it was 56 all the way down on the USB. But conversely, reading was a little bit faster on the USB than on the CF card. Block reads were exactly the same. Last thing I'm going to do is I'm going to do one of the tests with the transwarp, just see if there's a difference. There definitely is a difference between accelerated, not accelerated, and mostly in the writes, which I found interesting. The write times on both were in that 18, 17 K, and reads were 70s, low 70s. Whereas now you see it's almost 4 times as fast with the accelerator on writes, and reads were a little bit faster. but not that much. I guess about 20%, 25%. So that's interesting. And the block read, again, it went from 73 to 94. So let's try it on here. I'm going to have to figure out how to set the dip switches um, on this thing for making that card slot fast. Okay, we're back, and this is my final test that I've done for this video, and then I'm going to wrap up and do some summaries. I just thought on a whim, let me do something a little bit crazy different. And what I did is, if you look in here, this is a UtherNet II, an Ethernet adapter for the Apple II, and I've connected it up to my PC running ADTPro. I know it sounds like a security company, um, and mounted remotely two drives over Ethernet using the VE drive driver that they have for ProDOS, and it was able to mount up drives. And as you can see here, the drive I mounted was small, but that 85, couple notes, that 85 write speed might actually be the fastest write of the day. And in fact, it is. So over the Ethernet, that's faster than any of these other um, hard drive emulators that we have. Interesting, the reads were slower than the writes. Um, but the block reads, I think, were the fastest. They were not. The fastest block write was the Microdrive Turbo. The second fastest was the CFF card with a floppy mounted, as opposed to any other disk drive. I just mounted a 280 block floppy. And that might be because of the way it buffers, there isn't a whole lot to read. But this Ethernet block read was actually pretty fast. And if I might want to, as a follow-up, or I'll put it in the comments, I'll do a test with an 8 meg volume mounted across and let it do all four of the tests and see how it continues to perform. But I thought this was interesting. I also tested, we have a Yellowstone here, and I did the block read test to the floppy off the Yellowstone, and that only came in at 2 kilobits a second. It's floppy access, so that's what you would expect it to be, very slow. I think what I'm going to do now is I'm going to plot all these numbers into Mac numbers or Excel or what have you, and make a little graph showing the various speeds of the different cards with the different emulators. Okay, I thought I'd end here, a little wrap up. I put a summary chart together of all the storage devices we tested so far. Um, and there's three results that come from that. As I said, there's the writing of the file, the reading back of the files it wrote, and then it does a raw block read on the device. And in almost all the cases, the raw block read is the fastest because it's not, I believe, it's just getting a chunk of data, whereas with the file reads and writes, you're doing more ProDOS commands and overhead to do those. First, I just mentioned the Corvus. As you can see, more users on the network at the same time dramatically drop the performance. So that probably means that one station is getting all the performance it can from the disk server, um, and it's really driving it. But as you add more stations, if they're doing access at the exact same time, it puts more load on there, and the server can't keep up with that huge demand of reads and writes. The other thing I noticed is, almost every case, write operations were 30 to 50% slower than read operations. And in fact, the difference could be even bigger. If you look at the CFFA, it really takes a lot longer to write than it does to read. But interesting, its read performance at both the block level and the file level is almost the same. And in fact, that's the same for a couple of the others. The one notable exception to this read-write performance is the fast chip against the U, UtherNet II mounting ProDOS drives from ADTPro using their VE drive shim that they put on there. Writes actually happen faster than reads. That actually may be due to the fact that Windows can do some buffering for you. And in the case of, say, on a normal system, you know that if you just wrote something to the disk, you can read it back faster. But because of the way they may have implemented on the ADTPro side, it could be they can cache the writes and they don't have to actually wait for Windows to write them out. But on reads, they actually reread those blocks, and there might be just some little overhead thing. That was the one that was a little bit different. Clearly, the winner here on block performance was the Microdrive Turbo, and the CFFA and the Microdrive Turbo were kind of in line with each other. The Microdrive Turbo, though, in block mode on with a fast chip installed, you can see has the greatest performance. An anomaly I came across when I was doing this on the BootI, I was expecting better results on the BootI. In fact, I was thinking it would. I've heard that it performs as well as the Microdrive Turbo, but I saw some hiccups when I tried to have the Microdrive Turbo and something else in the machine, and I forget what it was, but it seemed to be performing slower, and it could be whether it's a conflict with the VGA card I'm using to record the videos or something else. I'm going to investigate that a little bit more down the road. Lastly, I did a test with a floppy drive, and the last two items are with a floppy loaded on the CFFA and hosted as a SmartPort drive. It still looks like a disk. If it isn't a copy protected disk, it'll work fine, and it can do block reads on that fast. But if you actually plug in a floppy, and I used the floppy EMU with a Yellowstone card, and you can say I believe the number was 2. It was getting 2K per second. So spinning disks obviously would be slower, and when you emulate the drive, say with the floppy EMU, it's going to be slower than, say, on the CFFA that emulates a floppy. It can read if you mount it as a block device. It obviously performs very well. I'm probably going to come back and I want to test the Yellowstone in SmartPort mode. I think it's going to be as slow as a floppy because it's just how it feels when I run it. And I want to redo some of these tests on the Apple II GS just to see how they perform versus the Apple IIe. I'm expecting that they'll perform along one of the seventh from the left says TW. That was me using a transwarp, which is a 3.5 megahertz or 3.7 megahertz Apple. I'm thinking it's going to perform along those lines with the CFFA card. So look for that update. I'll probably do a small video just giving you the results of some of those other tests in the next week or so. You can look for that. If you like this video, please give us a thumbs up. And if you haven't already, subscribe to the channel. Please do so.